creating a next word predictor using deep learning and natural language processing. We are going to break down the entire code step by step. So by the end of the video, you'll understand how you can train a model to predict next word in the sequence. Sounds cool, right? Let's get started. So first, let's take a look at the data. So we have a TXT file. So I've collected this data from a group chat, a WhatsApp group chat. So here is the data. Let's run this and check what's inside this data. So let's create a next cell and check what's inside the lines. So our line is a type of list. This lines variable is a list. Yeah, so it's a list. Let's print the random sentence from this word from this list. So let's 2233. So it is emoji, and let's check at -8th place. So we have a sentence, kal college bhi jana hai, with next line. So this is our data. So as you can see now, our data is impure, like it's raw data, and you can't just throw raw data to a model, right? You have to clean that data. So here is the code to clean the data and remove emojis and any special character in the data. So this is the code. We just have to pass the file path here, txt file path, and it will clean and return a list called results here. So let's run this cell, and after running we'll get results. And now we have a list called result. It Let's check what it's look like. So the type of result is list, I think. So yeah, it's a list, and let's check what's inside this list. So check the random line. So let's print an index of let's print -846. So minus 846. So we have a sentence or kaise ho with a question mark. So our data is cleaned. Now we don't have a next line character in the data. So we have to introduce that next line symbol in the data. To do this, we have to create an empty list and run a loop and add this next line character in the data. So yeah, it's done. And then we have to import necessary libraries. So these are the libraries that we are going to use while making this model. So now our data is in, it can be in uppercase or lowercase, or so we have to convert whole data in lowercase. So by this line, we will convert our data into lowercase. So strip.lower, this function will convert every line in the data into lowercase, and after that we will join every line and form a string sorry, form a string called full text. So let's check the type of this. So it's a string. So yeah, it's a string, and we have full data inside this variable called full text. Now we have to tokenize our data. So what is tokenization? This means converting each word into a unique number, which something the model can understand. So as we know that deep learning or machine learning model or any other machine don't understand words, English, Hindi, any other language. They only understand numerical or mathematical symbols or numbers. So we have to convert this data into numbers. So in order to do this, we have to make a tokenizer object of tokenizer class. So by this line, we'll create an object of tokenizer class. This class provides some functionalities. So this is one of them, fit on text. So this will convert, or this will provide index to every unique word in the data. So by this, word index equal to tokenizer dot word index. So this will convert, this will provide a unique index to every word in the sentence. So now by this code, we will convert every word into number. So let's check what it will look like. So let's print this and take a look. So it's total words, and here is our word index. So let's see. So here are the numbers of every word. So this function has mapped it with numbers, mapped every word of the sentence or the data to a specific number. And we have total 6,550 unique words in this data. So and every data, every unique word is mapped with a unique number. So we are done with tokenization. Now we have to create something called n-grams. So what are n-grams? Let's understand this. So let me create a new cell here. So to understand n-grams, let's take an example. Let's say we have a sentence that my name is Rocky. My name is Rocky. So we are going to predict name is and Rocky here. If I provide my in input, so I expect name as output, name as our output. And if I provide my name as input, so I want is as output. So to do this, we have to convert this into a supervised learning task. So we have to convert this into n-gram. So my name, then my name is, then my name is Rocky. Okay, so we have to do this of every unique word in of every sentence in the data. So to do this, we have to run this code. We have to write this code. So it will iterate through every line in the data, and it will create an n-gram sequence of every line, and it will append in the input sequence. So let's take a look how our input sequence will look like. So our input sequence should look like this, like a flag or a staircase. So let's check. So our input sequence is looking exactly like this, staircase. So we are done with that. So now, as we can see that every list here is of variable size. They are not same, right? It is of 2 length, it is of 3 length, then again 2, 2, 3, and these are of variable length. So to make it of same length, we have to pad it with zeros. So to do that, we have to find the maximum length of the sequence in the sentence. So to check the maximum length of the sequence, we have to iterate through the list and check the maximum length of the sequence. So here we have done that, and let's check maximum length here, maximum sequence length. So the maximum sequence length is 65. So now we have to pad every list with 65 zeros to make them of equal length. So we are doing this here. Input sequence equal to pad sequences, input sequence, maximum length, and padding pre. This padding pre is showing that we are adding zeros in starting. Means if we have let's say we have a sequence, like we have a sequence 2 comma 3, so we are adding 65 63 zeros in starting, like 63 zeros, 0 comma 0 comma 0 comma 0, like this we are adding 63 zeros in starting. We can also do this as post, but we are using pre here. So if you will write post here, so it will add zeros and the end of the list. So let's run this, and we have padded our input sequences. So now we have to split our data into x and y, or training and testing phase. To do this, we just have to write this code. So let me write the comment: splitting the data. So we are splitting the data here of input sequence from here to here and y from here to here, and we are converting into categorical data. So now here is the most important part of this. So we are creating a sequential model, or we are defining the architecture of our model here. So now we'll add a sequential layer. Sequential layer will sequentially uh, add all these layers in the model. So first layer is embedding layer. So embedding is a very important term in deep learning. So embedding is a method by which we can convert sentences in numbers, so that it can capture the semantic meaning of the sentence. It means if we have sentence that my name is Rocky, so it will convert my in 100 dimension vector. We are passing 100 here, so it will convert it in 100 dimension vector. So it will contain 100 unique numbers, and it will contain the contextual meaning of my name and is and Rocky. So this is the embedding layer, and now we have a LSTM layer, long short term memory layer, with 150 cells. And return sequence is true, that it will return, or it will give output at every timestamp, and we will get that output here. And we have another LSTM layer with 150 cells, and then we have a dense layer with softmax function. So what this softmax function will do, it will create a probability, or it will generate a probability of every word, of every unique word in the data. So we have 6,550 words. So here it will generate 6,550 unique probability of every word from 0 to 1. So at the end, at output layer, it will choose the maximum probable word in next word prediction task. So here we are using optimizer, Adam, and categorical cross entropy, and accuracy is metrics. So let's compile this code, and just model dot, will fit the code and start training. So model dot fit, and we will use epoch 20. So here are here is the trained model. So I have trained it for 20 epochs first, and reached 32% of accuracy, and after that more epochs, 20 more epochs, and then it reached 51% accuracy, and then I have trained it on 20 more epochs. Uh, it reached 61% accuracy, and then I have trained this on 20 more epochs, then it has reached 66% of accuracy. Then I have saved the model, and tokenizer.pkl. This will store the word indexes of the sentence or the data. So make sure to save the model, and save this pkl also. So now it's time to test the model. So here you have to pass the model path, and here you have to pass tokenizer path, and model sequence length, max sequence length. Sorry. So max sequence length is the length that we have used while training time. So it is expecting maximum 65 length input in the model. So here is the testing phase. So it is the code for testing. Here we will load the model and make predictions. So let's try this with this word. So I predicted it for this word. So it has predicted input is khana, and the predicted next words are khana wana, and then khana wana kha, and then khana wana kha liya karo, and meri party na bas. So it is predicting I think next four word very accurately. After that it is performing bad. So yeah, it's performing decently. So let's predict it with some more words. So let's try good here. So I think it will predict morning or something. It will take time. And there you have it. So yeah, it is predicting a good morning advance में. कितना अच्छा लगा तुम्हें आज मिल जाएगा. So yeah, it's predicting next three word I think accurately, and after that it is uh, printing rubbish. So yeah, it's performing pretty decently. So let's change it to three words and run this again. So yeah, it's predicting next three word very accurately. Good morning advance में. So it's a WhatsApp group chat. So what else we can expect? So here is the code for next word prediction. And of course, this is just a start. You can improve it by using bigger dataset, tweaking the model, or exploring other architecture like GRUs. But now you got the basics. So I hope you found this tutorial helpful. If you did, make sure to hit that like button and subscribe to the channel for more awesome deep learning projects. And yeah, in next video, I will make this model and convert this into a Streamlit app, as we have converted our F1 classification model into a Streamlit app. So stay tuned for next video, and we will convert it into a fully functioning app. So thank you for watching, and make sure to subscribe.